7.1, evaluating and solving formulas. Some of this is going to sound familiar, and I hope it does, because we have gone over some of it previously. This comes from 2.1. This was the slide that we looked at in 2.1. So remember the problems in 2.1, right? They showed values for letters or symbols, okay? And then what we did is we took those values and replaced the letters or symbols with those numbers. And then after that, it's just a matter of evaluating and simplifying. In this section, 7.1, though, it's going to be, there will be some evaluation and simplification, but there will also be some solving of equations. So in the past, where we solved directly for something, now it's going to be, it'll be in an equation that we then must solve. So, and we've seen this one before already. This is a formula, right, for the area of an open top box. Now it says L is length, width is W, height is H. So we know what to replace these values with. So let's look here. At the bottom it says find the surface area of an open top box with a length of 6 inches, width of 7 inches, and height of 8 inches. So I'll start with the length being 6 inches right here. And I'm going to go to my length and I'll replace any lengths I see with 6 inches. Alright, so there's a length and there's a length. Next up, we got width at 7 inches. So I find all my widths and replace those with 7 inches. So we got 2 right there. And then finally, the height of the box is 8 inches. So I find all the heights and replace those with 8 for 8 inches. Again, we've seen this before. We've done it quite a bit. And we're just replacing those values just like we did. And now this will allow us to solve for A. Now you could do this term by term, or you could do what we've been doing and just type it into the calculator. Well, you could type it in the calculator. Let's do it term by term, though, just so it shows all the work, even that the calculator would be doing internally, all right? So 2 times 6 times 8. 2 times 6 is 12. 12 times 8 is 96. There's that one. And then this next one, we got 2 times 7 is 14 times 8. Yeah, I'll use my calculator for that one, which is 112. And then 6 times 7, we should have that one at 42. So the area is going to be 96 plus 112 plus 42, which again, I can just put that in my calculator, plus that 96. Oh, I missed one. 96 plus 42. And that gives us 250. So the area of this box is 250. Now on the homework, I believe it's labeled for you, but just in case in the future you need to do this by hand, you need to label it because it is a word problem, all right? And they gave us the units down below in inches, as we can see here, like 6 inches, 7 inches, 8 inches. So to tack on a label for this one, it is in inches, but it's area. So it's actually in square inches, like this. All right? Now again, that means that it's square inches, not that the 250 is to the power of 2, right? Hopefully we remember that. All right, so again, we get this formula for the area of a trapezoid. 1/2 times base plus the other base times the height. I believe we've seen trapezoids before, and hopefully we remember them. And the two bases that they give us here, we got the lowercase b base and the uppercase b base. It's not like the uppercase B needs to be the longer of the two sides, but we do need to remember that the bases of a trapezoid are the two sides that are parallel to each other. Now the red side here, we'll get to that, but I'm just ignoring that for now. And I'm looking for the two sides that are parallel. So I got this one, which is parallel to this one up here. Alright, so those are my two base values. Alright, so just identifying the two bases, right? I got this little one right here, and that shows at 11.8 centimeters. So I'm going to replace this B with that 11.8. And we got this other base. Again, it's just the two parallel sides. That's why I have it in green right there, which shows at 29.5 centimeters. So, and again, it wouldn't matter which of these you placed where. So the green one could be the 11.8, and the purple one could have been the 29.5, okay, in the formula for trapezoid. They just need to be parallel to each other. So I got 29.5 right there. And also, we're given that red side right here. Now that red line we do need, okay, and it doesn't show it, but it does create a 90-degree angle with both of the parallel sides. And that's how we know what the height of a trapezoid is. So the height on this one is that 23.6 centimeters. So we'll need a little bit more space there. So the height we'll replace with 23.6. Whoops. Like this. Alright, so if I fill in the rest of the formula, this stuff was in parentheses, which was adding to each other. We'll take 1/2 of that, and that would, after multiplying by 23.6, give us the area. Now, keep in mind with a trapezoid, before we solve this, and I'm just going to put it in my calculator, by the way, a trapezoid only has one set of parallel lines, which is why we classify it differently. If it had two sets of parallel lines, then it would be a rectangle, or just a parallelogram, okay? So that's what separates a trapezoid from regular parallelograms or rectangles or squares, okay? So let's go and put this in the calculator. So I got 1/2. Again, I can use the fraction button for that. I'm pushing to the right on the cursor to get out of the fraction. I'm going to use my parenthesis button. I have 11.8 plus 29.5. Then I close that parentheses, and then I see that I didn't put the 23.6 in parentheses. You could have for the calculator purpose, but we actually don't need to, because the calculator knows that if we don't show the operation, that it assumes it's multiplication right there. So I have it all typed in. You can see I push enter, and that gives me this value. The area is excuse me, 487, and I got 0.34. I think that's exact on that. And again, this is just a word problem, so we just need to remember to label it. Again, on the homework, it may be labeled for you, but on a written test or a written quiz, you would need to label it for yourself. 487.34, we see it's in centimeters at least, so we know we're going to have centimeters, but it's area, so it's square centimeters, okay? And yeah, remember there's that second way that we can write area, or labels for area. In this case, it's centimeters squared. So either one of these would work. All right, using the formula, A equals L times W, that's area equals length times width. Find the length of the rectangle with length 29 inches if the area is 493 square inches. All right, so they gave us that formula up there for the area, and this would be for a rectangle. Area equals length times width. Now they gave us the length on this one at 29 inches. So again, in the formula, I would replace the L for length with 29. And then they also said that the area is 493 square inches. So this is not W, obviously. It's not the width. It's just the area on this one, 493. So I replace A with 493. Now writing this out, what I end up with here, as you can see, 493 equals 29W. So that's 29 times the width. If I just wanted the width, this is just solving a one-step equation, you guys. So hopefully you will remember to solve an equation like this, one step, where we have 29 times W. I don't want 29 W's, I want 1 W. So how do I change a 29 to 1? By solving an equation, I would use the division property of equality by dividing both sides by 29. So 29 divided by 29 is 1. 493 divided by 29, you could use long division if you wanted to, but I'm going to use my calculator. 493 divided by 29 is 17. Now be careful because, like I said in the past, a lot of students, I mean, this was some good work here. And we feel pretty good about 17. It's just, don't forget to label your answer on a question like this one. And this one was shown both labels in either inches or square inches. So this one is just 17 inches. Find the Celsius temperature reading if the Fahrenheit reading is 50 degrees. All right, and they gave us this formula. As far as I know, this is not a formula that you have to memorize, so here it is, okay? So I'm going to rewrite this out, actually, because it is a little bit more involved here. Celsius equals... So this is what we got as a formula, and then it says that the Fahrenheit reading is 50 degrees. So I go to this formula, I replace F for Fahrenheit with the degrees that it is in Fahrenheit, which it said it was 50 degrees. So, again, you could kind of use the order of operations to solve this, or you could just type it into the calculator. This one's not too bad. So I'm going to do the parentheses first, actually. 50 minus 32 would be 18. So as of right now, the Celsius will be 5 times the 18, and we'll just take it and divide it by 9. And then we got 5 times 18, which is, what is that, 90? So 5 times 18 is 90. Celsius now is equal 90 divided by 9. And 90 divided by 9, hopefully we got that one pretty quick. That's 10. All right, so again, it's not just 10, by the way, for an answer like this one. It would be 10 degrees. You can just put C for Celsius. And that would be our answer for this one. All right, so those last few problems that we just did, hopefully that's a good exercise because we've seen some of those formulas before, which is really just kind of a precursor, I guess. Maybe hopefully I'm using that word right, but it's helped us to review what we've seen before, and we've seen some of these before as well, okay? But just keep in mind, for this, the rest of this section, we're going to see a lot of formulas like this one. Y equals negative 5x plus 15, and we'll see a different format, which is what we will look at after we look at this type of equation, all right? But there's something about this formula, just to start out with, that we need to notice, okay? It's got two variables, and they have to give us one in order to solve for the other one, okay? But there's some other questions that should come up as we look at formulas or equations like this one. So this formula, and I'll just rewrite it here. Y equals negative 5x plus 15. And right here they tell us what x is, okay? So x equals negative 4. So I'm going to take this x, I'm going to replace it with, well, negative 4. So now the formula replaced x with negative 4 is y equals negative 5 times negative 4 plus 15. So this then becomes an order of operations problem, and yes, you could type this into the calculator like we see it. I'll just do it by hand because there's nothing too extreme on this. Negative 5 times negative 4, that should give us positive 20. And then we'll add 15 to that, which will tell us what y is. And then 20 plus 15, bam, 35. So y equals 35 on this one. And that would be our answer on this one. Okay. Now, I want to point out that when x is negative 4, y is 35, okay? So these two values actually do correspond with each other. And I'm pointing this out now because when we get into the next section, maybe it's 7.3, we need to remember that these two values correspond with each other, okay? Because it's going to create a relationship which we can actually show in different ways. So this is the other format that we're going to be seeing in these formulas. And again, we're going to call them equations, but in this section we can call them a formula. It doesn't really matter. So again, I'm going to rewrite the equation just so I can replace the y value with 1, as it says right there. All right, and then, again, it says y equals 1. So I replace my y value just like I would in the other formulas with the value 1. All right, so rewriting the equation, 4x plus 7 times 1 equals 27. So at this point, I have a one variable equation, which we're just going to solve for with the principles of equality, or just the basic or standard process for solving an equation. So, right, we got 7 times 1. That's not too bad. 7 right there. And if we hopefully remember, looking back at Module 2, this now is a two-step equation. So, I don't want anything added or subtracted to my x's, even though there's 4 of them. So I need to get rid of that plus 7, right? So I need to subtract 7. But as a principle of equality, I need to subtract it from both sides of the equation. And 27 minus 7 is 20. So I now have 4x equals 20, right? The 7's zeroed out. And to solve this, I don't want 4x's, I want 1x's. So I'll just divide both sides by 4. And that shows a 1x right there. 1x equals 20 divided by 4 is 5. And that should be our answer right there. And we could check, right? So our formula was 4x plus 7y equals 27. So I can take 4x plus 7y and just see if it equals 27, right? So I put a question mark over that equal sign, where the y is 1 and x is 5. And we see that this is going to work out. 4 plus 5 is 20. I'm sorry, 4 times 5 is 20. 7 times 1 is 7. And 20 plus 7 is 27. So we get something that equals itself. And again, that was just checking to make sure that it actually was equal. And yeah, you could have typed it in the calculator to check that. But I like to show the work on this so you guys can see how you would type it into the calculator. So we've checked to make sure that it works. So in this case, when y equals 1, then x equals 5. Again, that creates a relationship between the y and x value. All right, same type of formula on this one. 8x plus 5y equals 43. And we're going to find x when y equals 2. So let me, again, I'm just going to rewrite the formula. And it tells us that y equals 2. So I replace the y in the formula with 2. And again, this sets up just solving a equation for x. Now this y and x business, you guys need to get used to it again, because the equations that we're going to look at from here on out, and you're going to see a ton of it in not only 980 but 1010 and any future classes, math classes that you take. So yeah, let's go ahead and solve this, right? 5 times 2, that's 10. And I should, well, again, hopefully we see that this is a two-step equation. I don't want that plus 10 there, so I'm going to zero it out by subtracting 10 from both sides of the equation. That does zero out. I'm left with 8x equals 33, I guess. But I don't want 8x's, I want 1x's. So I'll change that by dividing both sides by 8. That shows 1x. X equals, I'm just going to keep this one as an improper fraction. The decimal on this one's not too bad, but the improper fraction is just faster. So I think it's easier. And again, you could check this, right? So just going to the calculator, you'd have 8 times 33/8. And then you would add 5 times 2. And when I push enter on my calculator, I should get 43, right? Which is what it shows in the equation. And the calculator shows it is 43. So we can box this in with confidence. When y equals 2, x is 33/8. And again, this creates a relationship between the y and the x value. Now, before we move on to 7.2 on this, keep in mind what these formulas are, right? In the future, they're not actually going to tell us a value of y. Okay, what that means is that we get to choose a value of y. So, where in the past we have seen equations and we solved for one of the variables, we're going to see two variables in equations, like this example or the other example. But you have to choose for yourself what values of y you would want to create. Now, keep in mind also, as a real-life application of this, in some cases, you're going to be comparing two quantities which you would know. So we say there's a relationship between x and y, which we haven't really covered yet. But in the future, you'd find two values that have a relationship, such as like time and money, right? Like if you go to work and you work for 40 hours, then you get paid a certain amount. Okay, and if you know your rate, then you should be able to know how much you would get paid for maybe 30 hours, let's say, okay? So that creates a relationship between two quantities, like we've seen, between y's and x's. And it actually shows a relationship which can then be shown in different ways, which, again, we'll look at. And an equation is one way to do it, and we've gone over how to write equations, but, again, in 980, you're going to be looking at even more in-depth ways to write equations.